Assalamu alaikum dear students. Today we have a solo here where it is saying infer the following states of a body based on the given graph. We will discuss four cases in a speed time graph. The first one is when the body is at rest, when the body is moving with constant speed, when the body is moving with positive acceleration, or it is moving with negative acceleration. So we'll cover all the cases here using different types of speed time graph. So in the first case, you can see if you have a straight line, and that straight line, if it is passing through this time axis, if you have a straight line and if it is passing through the time axis, you need to understand that our velocity in this case is 0. And if our velocity in this case is 0, it means that the object is at rest. So if you have a speed time graph and the line is passing through the time axis, along the time axis, then you need to say that the object is at rest. Now how it is so? Look, with the passage of time, you can have different values of time here if you go from from this side to that, but at these wherever you go in this time axis, there is 0 value for v. That's why we can say that it is at rest. The same can be represented in acceleration time graph here. In acceleration time graph, we will have a straight line and it will be passing through the time axis. So both cases, the graphs here, they are showing that the body is at rest. So this was the first case. Then we have here, you can see another speed time graph we are having here, but this time we have a straight line that is passing through the y-axis, or in some case it can also pass through origin. Like we'll have straight line here, but it will pass through origin. In both cases, your acceleration will be constant. You can see the velocity with the passage of time, it is changing, but the rate of changing of velocity is equal. So velocity is changing equally in equal interval of time. It means that we will always get equal value for acceleration. So if you have okay, next case we are having here another graph, vt graph here, but this time we have straight lines, and these straight lines are passing through the v-axis, the speed axis, but there is only a slight bit little bit difference between these two lines. And what is that difference? This line is having more slope as compared to this one. We know that speed time graph, in a speed time graph, slope gives us acceleration. Yes. So if we have different slopes here for this line, we will have different acceleration, and if the slope is greater, then the acceleration will be greater. If the slope is lesser, then the acceleration will be lesser. So in this case, acceleration is more. Why? Because the slope is more. Now in this case, the slope is less, so acceleration is less. But you need to understand that in both cases, we will have constant acceleration throughout the journey. The acceleration we are getting is constant, it is same. Okay, now in third case, we have again speed time graph here, but this time you can see the value, there is non-zero value for speed. Look, when time was 0, at that time there was non-zero value for speed. Let's say it is 4 meter per second. Now you can see with the passage of time, the speed of the object is not changing, it is going with the same speed. Now look, if we'll draw we'll find the value of velocity here, we'll draw line on this axis, v-axis, and time axis. So if I am checking at 1 second, the speed is same. If I am checking at 2 seconds, at that time as well, the speed is same. So look, with the passage of time, the speed is not changing, and we know that acceleration is equals to del v by del t. The change in velocity is called acceleration. If there is no change in velocity, then acceleration in this case will be equal to 0. The acceleration in this case is 0. This graph shows constant velocity and 0 acceleration. Now in the below graph, you can see here the velocity is also changing. Here we have change in velocity, but with the passage of time the value of speed is going down, it is reducing. With the passage of time we are having less speed. Now if we will check here at this point, and if I will assume it to be 1 second, then at that time the speed was 5 meter per second. But after some time, if I will check, let's say at 2 second, there is not the same speed here at this particular point. Now here it is, let's say 4 meter per second. Now at this point, if I will check, it can be 1 meter per second. Now look, there is change in speed is changing, but the value of speed throughout the time, when the time is changing, it is reducing. So whenever you will have change in velocity, and that change is, if it is reducing, if it is going down, at that time we call that acceleration as negative acceleration or deceleration. So if you have this type of graph that is going down, then you will say that we have here deceleration, we have here a retardation, we have here the object is losing its speed, or we are applying brake when we are moving on a road in our vehicle. So now we will move towards the next case. Okay, now can you guess about this one? Is it acceleration or retardation? Okay, I'm giving you time, just think and then tell me. Okay, well, in order to check that whether it is whether in this graph we have acceleration or deceleration, I told you the speed time graph. In a speed time graph, the slope of the graph will tell us about acceleration. Now as you can see here, with the passage of time, here the slope is more. At point A the slope is more as compared to B. Now at B the slope is more as compared to C. Now at C the slope is more as compared to D. So it is going down. Now look, if our graph, our line is more inclined towards V axis, speed axis, it means that we are having more slope. If it is inclining more towards the time axis, it means that our slope is less. If our slope is less, it means that our acceleration with the passage of time, the value of the acceleration is also less. So it is, now in this case there is deceleration. Remember this, there is deceleration. Why we are having deceleration or retardation here? Because with the passage of time the slope of the line is decreasing. If the slope is decreasing, it means that acceleration is also decreasing. Now I think we have the last case, that is, what if we have positive acceleration? Okay, now let's say I will plot a graph here. This is my velocity and this is time. Now in this graph you can see some value here. Okay, one I can draw like this. Now if you have a graph, and in that graph the velocity is changing, and this change is not uniform, this is also called acceleration. But here it is not changing uniformly. Let's suppose if in 1 second the speed here is 3 meter per second, but in the next second here, okay, let me redraw it for you. Okay, let me redraw. Yes, let's suppose we have this graph. Now in 1 second, if my speed is 3 meter per second, now in the second one it is 5 meter per second. Now the change is huge here. In the first 1 second it was 3 meter per second, but in the second, in the next second, it was 5 meter per second. So look, the change is greater. We can see that the slope is also increasing. So we have acceleration here, but this acceleration is not uniform. And if you will talk about acceleration, you can see here we have positive acceleration here. Then if you'll compare these, the graph which is having the line which is having more slope will have greater acceleration. Thank you for watching.